NASA has released images of a never-before-seen phenomenon where a star named Betelgeuse blew its top off and ejected a gigantic portion of its surface mass. This event is known as a surface mass ejection (SME), and according to the space agency, the ejection was 400 billion times the mass of an ordinary solar flare from our Sun. Scientists have termed the event as watching stellar evolution in real time. A star blasting off such huge chunks of its physical form has surprised many, and the catastrophic explosion of this super red giant is upsetting a lot of what we know about the universe. Why did Betelgeuse blow off its top? How will that affect the universe? Let's find out. Constellations are made up of many stars and are arranged in accordance with mythology and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the largest and brightest stars in our night sky. The brilliant ruby red, glittering star known as Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. When viewed tentatively, it appears to be a peaceful, shining star, but astronomers recognize it as a seething monster with a 400-day-long heartbeat of regular pulsations. Due to its dismal orange-red color, Betelgeuse is easily identified and is ideal for convincing doubters that stars do, in fact, have different colors. Also known as Alpha Orionis, it is the second brightest star in the constellation, after the blue supergiant Rigel. Betelgeuse is an intriguing object for star studies and observations due to its variable nature and odd name. Frequently, stars with the name Alpha are the brightest stars in their constellations, even though Rigel, Orion's other bright star, is brighter. However, Betelgeuse is named Alpha Orionis due to its brightness, size, and reddish hue. It is also one of the most well-known stars, even serving as the model for both the character and the movie Betelgeuse. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and the 10th brightest star overall in the sky. Earth is relatively close to Betelgeuse, though astronomers are unable to pinpoint its exact distance from Earth. They believe it to be between 430 and 724 light-years away. Betelgeuse is the brightest red supergiant star closest to Earth, and only about 200 red supergiant stars have been identified in our galaxy. This massive star has a radius around 764 times larger than the Sun. If Betelgeuse replaced the Sun in our solar system, it would extend past the asteroid belt and beyond Jupiter, meaning Earth, Mars, Venus, and Mercury would all be completely absorbed. Betelgeuse is also 16.5 times as massive as the Sun, with 126,000 solar luminosities, and is visible from 548 light-years away. With a surface temperature of 3,600 degrees Kelvin, Betelgeuse is cooler than the Sun, and only about 13% of its radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would overtake Sirius as the brightest star in our night sky. Betelgeuse loses about one solar mass every 10,000 years. The red star is surrounded by a nebula of material being ejected unevenly from the star in all directions, forming a cloud 250 times larger than the star itself. The size of this nebula is thought to be around 30 astronomical units, or 30 times the distance between the Sun and Earth. Our solar system's Sun regularly ejects mass into space, known as solar flares. However, the Sun only exhales tiny fragments of its outer atmosphere, known as the corona, giving rise to the term coronal mass ejection (CME). Stars can eject portions of their unstable outer atmospheres, causing CME events, which occur frequently in our solar system and can impact Earth by affecting satellites and power infrastructure, or even putting astronauts in orbit in danger. The recent discovery of the Betelgeuse SME sheds light on its dimming in 2019 as material ejected into space cooled, producing cosmic dust that obscured its brightness from Earth. The CME on Betelgeuse was 400 billion times more massive than a typical CME, causing the star to tremble. According to NASA, this event disrupted Betelgeuse's internal convection cells, while the photosphere, or the star's surface, struggled to rebuild itself. Astronomers have tracked the star's constant pattern for 200 years, but now it seems that its behavior has changed. All red giants, including Betelgeuse, are perishing, and being able to observe this process will allow researchers to learn a lot about the evolution of stars. The majority of stars in the cosmos are powered by nuclear fusion, which eventually burns out and causes a star to undergo a series of intriguing stellar changes before it finally perishes. When a star is born, it is made of hydrogen, which under the force of gravity fuses together in the star's core to create helium in a nuclear explosion. A lot of heat and light energy is typically released during the fusion process. This energy travels to the star's surface and is released as a photon into space. As the star ages, its primary fuel hydrogen runs out and helium starts to combine with carbon to form carbon. After the helium is used up, neon will eventually combine with carbon to form iron. When this happens, the fusion of neon with iron absorbs the energy instead of releasing it. Because there is nothing to oppose the star's very powerful gravity, when iron begins to fuse, the star collapses in on itself, giving rise to a supernova explosion. A supernova, one of nature's most powerful forces, can generate more energy than 10 billion suns. Stars change hue during the course of their existence, from the youngest, hottest blue forms to the older, cooler red varieties, depending on what stage of their stellar evolution they have reached. The Greek scientist Ptolemy 90 to 168 AD strangely referred to Betelgeuse's color as having a ruddiness, yet 3 centuries earlier, Chinese astronomers had characterized the star as having a yellow appearance, possibly implying that Betelgeuse was formerly a yellow supergiant. Larger stars frequently burn through their hydrogen faster and die off sooner. Despite being only roughly 10 million years old, Betelgeuse is certainly nearing the end of its lifespan. Our Sun, on the other hand, is still in its prime at approximately 5 billion years old. Furthermore, because Betelgeuse is nearing the end of its life, it's possible that a supernova will occur soon. Betelgeuse undergoes 2 dimming and brightening cycles, the second of which occurs approximately every 5 years and lasts about 100 days. The star's outer shell is thought to expand and contract during this cycle, changing the star's circumference and average temperature in accordance with each step of the cycle. Astronomers may gain a better understanding of how red stars lose mass in their last days before exploding in a bright supernova from Betelgeuse's explosion. As Dupree notes, we've never before seen a huge mass ejection on the surface of a star. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We're watching stellar evolution in real time, but it's unclear whether this development portends Betelgeuse's impending supernova explosion because the results are so unusual. NASA issues a warning that Betelgeuse may not have reached the end of its life. Even if it is, cosmic time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the focus of intense studies since the 1st century BCE. More recently, a scientist by the name of Serafina Nance and her team sought to ascertain the potential timing of the supernova explosions of red supergiants like Betelgeuse. To find out how a star that large would behave over time, Nance and her team ran multiple simulations using Betelgeuse as a model. They then contrasted their findings with field observations. Why did Betelgeuse diminish suddenly and out of sync with its regular cycle when it won't likely explode for another 100,000 years? Betelgeuse was evicted from its home in the Orion OB1 association, which comprises the stars in Orion's belt, and has been seen moving through the interstellar medium at a speed of 30 kilometers per second. More than 4 light-years wide, a bow shock is being produced by this speeding star. By mid-February 2020, Betelgeuse had lost around 3 times as much brightness, from magnitude 0.5 to magnitude 1.7, after beginning to decline sharply in October 2019. By February 17, 2020, Betelgeuse's brightness had been stable for almost 10 days, and the star had started to brighten once more. However, Betelgeuse appeared to have stopped dimming completely 5 days later, effectively ending the dimming episode. Given that there were no significant changes in the infrared on February 24, 2020, it appeared that the recent visual fading was unrelated to the anticipated core collapse. Another study that day concluded that the star's dimming was most likely caused by occluding large-grain circumstellar dust. Dust absorption was ruled out from having a significant effect in a study that used measurements at sub-millimeter wavelengths, but the fading appeared to be caused by large star spots. Further analysis showed a dramatic rise in Betelgeuse's brightness between May and August. Betelgeuse is so close to the Sun that it is almost impossible to see from Earth before 2020, when Betelgeuse will be in conjunction with the Sun. It was 0.4 brilliant according to the observations made with the Stereo satellite in June and July of 2020. The star had faded by 0.5 since its previous ground-based observation in April. Everyone was surprised by this because the maximum and subsequent minimum were expected to occur in August-September 2020 and around April 2021, respectively. Betelgeuse's brilliance was known to shift wildly, making predictions difficult. The fading seems to indicate that a second dimming event may occur much sooner than expected. The finding of a second dust cloud coming from Betelgeuse, which was linked to a recent considerable dimming of the star's light, was revealed by astronomers on August 30, 2020. In June 2020, it was suggested that a cool patch on its photosphere might be the cause of the dust, and in August, a second independent investigation confirmed the initial hypothesis. The dust is thought to have been created by the gas that the star had spilled cooling. According to studies done in 2022 using the Hubble Space Telescope, occluding dust may have been created by a surface mass ejection. The material was ejected from this star's surface millions of kilometers away, where it cooled, compacted, and formed the star's fading dust. The broken photosphere, which was roughly several times as heavy as our moon, went off into space, cooled, and created a dust cloud that covered the star from the perspective of watchers on Earth. The fading, which began in late 2019 and continued for a few months, was plainly discernible even by backyard observers who observed the star's brightness change. Even more remarkable, the 400-day pulsation rate of the supergiant has vanished. For around 200 years, astronomers have been tracking this cycle by analyzing changes in Betelgeuse's surface motions and brightness variations. Its disturbance reveals the extent of the blast. Astronomers have now developed a potential theory to account for the disruption. The star is also slowly but surely rebuilding strength, and the photosphere is regenerating. The star's normal cycle is being thrown off, and the interior is vibrating like a bell that has been slammed. A massive stellar surface mass ejection has never before been observed. There is still something going on that we don't fully comprehend. We may directly observe this brand new phenomenon and use Hubble to discern surface features. Real-time observation of the development of stars. What time will it occur? Probably not in our lifetimes, but in fact, no one really knows. It could be tomorrow or a million years from now. Thanks for watching another episode of Nebula Lift. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.